Good, so this is the next video in section 4.1. We're in the first video we talked about how to compute the distance that we've traveled, and we found that the distance that we traveled could be computed by finding the area between the curve and the t-axis here. So positive area means you're moving to the right, and negative means that you're moving to the left. Okay, so let's continue that now with this example. Suppose that this is my velocity function, and just to be specific, we'll use miles per hour, although this is going to be very slow since we're just moving at 2 miles an hour and we're moving over 6 hours. Okay, so let's go ahead and see where we are. And in this case, I'm going to use some different colors here, maybe. And we're going to figure out the difference between displacement and distance for each value of time. So for different values of time, we'll compute the distance traveled, and then we'll compute the displacement, which is also the position at different times. Okay, so let's go with time 2, time 4, time 5, time 6. Okay, so at time 2, right, at time 2, I have traveled this much, and this is geometrically, right, this is the triangle, and so the distance traveled is just going to be the area of this first triangle. Let's call it A1 maybe, and so the area is going to be 1/2 base times height, which simplifies to just 2, it looks like. Good, and the displacement function or position function, we've still moved 2 units to the right, so we've added 2 to the right. Now I don't know where I start, is why I'm saying I'm adding 2 units to the right. I don't know where I started. If I started at 0, then this would just be a 2, but I don't know that I started at 0. Okay. Now at time 4, that's at this time, my velocity is moving from positive 2 to 0, so I'm slowing down, and then finally I stop at time 4. Okay, and so this is another 2 units, so I'm going to total distance traveled is 2 plus 2, which is 4 units to the right. Okay, now similarly for the displacement, we add 2 units more to this, so we've moved altogether 4 units right. And this is starting at time 0, right? We've moved 4 units to the right. Now at time 5, this is where the 2 things are going to start to differ, right? Because now the area here this is a 1 by 1 triangle, so I've moved 1/2 unit to the left, right? But distance, it doesn't matter. I've traveled another 1/2 unit, so this would be 4.5. And just to finish off the distances, right, I would just add this area here, and so this is another 1/2 unit, so 1/2 plus 4.5 would just be 5. So this says that I've traveled 5 units total. It doesn't matter right or left, I've just traveled 5 units, so that you could think of that as miles if you like. Now displacement is going to be different. I've moved 4 units to the right, but now at time 5, I've now moved 1/2 unit to the left. So if I move 4 units to the right and then 1/2 unit to the left, I'm now at 3.5 units right. And then finally, the last point here, I've moved another 1/2 unit to the left, and so therefore we are at 3 units left. Okay, now this is starting, we have to be careful here because we don't know where we started, and we're going to talk about that in just a second. But this is the difference between distance traveled and displacement. Okay, so distance is always, think of it as always positive. Displacement or position could be positive or negative because it has a direction. Positive will be to the right, typically. Negative to the left. Good. All right. I think we'll pause and we'll set up another example. Okay, so continuing with our examples, the last one we looked at was a graphical example, and now we want to think about a tabular example and an example in data. And so here's my setup. I've got some kind of oil leak. Do I have a very good focus on that? Whoops, probably not anymore. Oh, there we go. Oil leak with a rate of change of R of T liters per hour. And so I've got times here, times 0, 2, 4, 6 hours, and then these values will be in liters per hour. So this is 9 liters per hour. So initially we're losing oil at a rate of 9 liters per hour, and then after 2 hours we have 7 liters per hour, and then at time 4 we have 6.5 liters per hour, and then at time 6 we have 5 liters per hour. So that's how to read that graph. Okay, so now the question is, how much oil have we lost? So can we estimate oil loss for time 0 to time 2? Okay, well, there's several ways to do this, so there's not a single right answer. Notice that the oil rate loss is going from 9 liters per hour to 7. Now we don't know that this is a nice continuous drop here, but you could probably assume that if you wanted to. However, we know that we start with 9 and we end at 7. So what would an overestimate be to overestimate the amount of oil that's lost? Well, it seems like it's reasonable to say that an overestimate would be to assume that your rate of change is going to be the maximum value over the entire time. So instead of saying that it's 9 just at time 0, we'll assume that it's 9 from 0 to 2. And so if we have 9 liters per hour over 2 hours, that would be 18 liters, right? And so that would be an overestimate for that first time. And similarly, how would you get an underestimate? Well, you don't want it too far under, right? So you could say, so my estimate's changing from 9 to 7. So let's use the lowest value there that I see, and that's the 7. So I could say 7 liters per hour. And I'm assuming now that that's over the 2 hours. That's how we're getting the estimate, right? We know that it wasn't 7 over the 2 hours, but we'll assume that it was. And so that would give us only 14 liters over the 2 hours, right? Good. So that's going to be a difference of 4 liters. So depending on whether you want to get an overestimate or underestimate. So similarly, you could do the same thing for the next time interval, right? So our over value would start at 7 and end at 6.5. We'd use the 7. So we'd use 7 liters per hour for 2 hours. So this is for time 2 to 4. And then our underestimate, we'd use the smallest. So that'd be 6.5 for 2 hours. Okay, so that'd be 14 liters or 13 liters. It's pretty close. Good. And then similarly, our last time interval from time 4 to time 6. Our overestimate, we'd use the biggest value of 6.5, and then we'd have our 2 hours, which would give us our 13 liters. And then our underestimate would be using the 5 over the 2 hours, which would be 10 liters. Good. Now let's put that all together. So for the full time interval from 0 to 6, right, we could use an overestimate of 2 times, now 2 is going to be the width of our rectangles here, so maybe it's good to give a little plot here too. At 2, 4, 6, and at 0 we're at 9, and then we're at 7, and then we're at 6.5, and then we're at 5. Okay, oops. And so this is where I better use a couple different colors of ink here. So for the overestimate, we're taking the biggest value over those points, and so these are the three rectangles we're using. And so notice the width here is going to be 2 units, right? And then it's going to be 9 for the first height plus 7 for the second height plus 6.5 for the third. And then the underestimate will be 2, that's the width of the rectangles. But then now we're going to be using the smallest height, right? And so the curve itself is going to be somewhere in between. So it may look like this, right? And so for the red rectangles, we would have 2, and then our first height would be 7 plus 6.5, and then our last height was 5. Good. So then what are we getting for our overestimate? Hang on one sec. All right, so now we can see what our estimates are here. Whoops. Sorry about that. I ran off the end of the page. So using the overestimates, we get that we lost 45 liters per oil of oil. Let's see if I can say that again. We lost 45 liters of oil over the 6 hours of time, and then our underestimate would be 37 liters of oil over the 6 hours. And of course, you could see some other ways of getting the estimate, right? So instead of estimating that the rate was constant between these times, you could just take this triangle here and then make this take this shape instead of a rectangle, and then that shape, and then that shape, and then add those 3 areas together, and that would be another way. Of course, that's assuming that it's just nicely falling in a linear way from 9 to 7. We don't know that that's true, right? We're just assuming that. Good. So that would be an even better way to do it. Another way that people will use that we were not going to get into very much is we could use the midpoint if we knew the data at the midpoints, and then we could try to find, you could use that as your height estimate, right? But of course, in this case, we only have our 4 data points, so there's not much data there. Good. All right. So that's it for this example. We'll start a new example in the next video.